Let's look at another question on WASSCE November 2013, question 8b. This is our diagram. In the diagram, O is the center of the circle. So here, this circle, O is the center, and PR is a tangent to the circle at R. So PR, from P to R, is a tangent to the circle at R. A tangent is a line that touches a circle at a point. So it is touching a circle here. Okay, and here is 90. Okay, there is also an angle properties of a circle. One of them states that when you have a radius and then you see from the O to R is a radius and then this is a tangent. Okay, when a radius and a tangent meet, or if they intersect, they meet at what? At a right angle. Okay, so even if you get a question and you have a radius and you have a tangent, you should note that the radius and the tangent, they will meet at a right angle. So here it will definitely be 90 degrees. All right. Okay. And watch a video on the circuit theorem. All these properties are there in our channel. If PR is 12, the PR is 12 centimeters, and PQ is 8, P to Q is 8. Calculate I, the radius. So we are going to calculate the radius of the circle. And where is the radius? We can see that the radius of the circle is here. No, the radius of a circle is a point at the center, a straight line from the center of the circle to any point on the circumference. So here is the radius, here is also a radius, from center to circumference, from center to circumference. So OQ and OR are all radius. So OQ, the radius is OQ, it is also at OR. And we say radius is small r. Alright, so radius is the OQ and the OR, they are the same. So if we see the diagram critically, okay, if our radius is OQ and OR, then here is 90 degrees, then this is what? A right angle triangle. OPR or ORP is a right angle triangle, where if the 90 degrees, the side opposite 90 is OP. This side becomes the hypotenuse. We have the hypotenuse and the other two sides. All right. Okay. So we can say that OP, okay, from the Pythagoras theorem, you can say that the OP square is equal to OR square plus RP or PR square. Okay. So the hypotenuse square from O to P is equal to this square plus this square. So what is our OP? Okay, we know that from OQ is what? R. So R plus 8 will give me what? The OP. So from O to P is the radius plus the 8 centimeters. Alright. So R plus 8 all squared is equal to OR is R squared plus RP, which is what? 12 squared. Okay, I believe you get it. So simple as it is. All right. Okay, so what we are going to do is to expand this, and so we have our R plus 8 all square equal to R squared plus 12 squared. So this can be R plus 8 R squared plus, what is 12 squared? 144. Then R times R will give me R squared, R times 8 will give me 8R, 8 times R will give me 8R, and 8 times 8 will give me 64. Alright, equal to R squared plus 144. Okay, so what we are going to do is to group like terms. Alright, okay, so I'll bring the variable at this side. Okay, and there is an R squared here and R squared here. Okay, since there is square, there's a probability that we can get what? A quadratic. And if that happens, we bring out at one side and equate it to 0. But let's see what the quadratic is. R squared. Here is positive here. So if I bring it here, what it need to be R squared minus R squared, and the R squared will be 0. So R squared will go. Okay, because of that, then let me bring the R at this side and take the constant at this side. Since the R squared will go away. Okay. So I'll have R squared. 8 plus 8 will give me 16R minus R squared equal to 144 minus 64. Okay, so r square is here, 8r plus a 16r. Then I bring this r square to be minus r square. Then I have 144 minus 64. Alright, so this will take up this. So I have 16r to be equal to. So 144 minus 64 is going to give us what? 80. Okay, 80. So my r is going to be 80 on 16. Okay, 80 on 16. So what is 80 divided by 16? That is 5. So the radius is 5 centimeters. So the radius is 5 centimeters. Therefore, radius is equal to 5 centimeters. So our radius is 5 centimeters. Right, it's so simple. Then we are going to find the length of the minor arc QR. We correct it to 2 decimal places. So my minor arc is here. The length of the minor arc. So this is the minor arc. Alright. QR, we say QR. So the minor one. So from here to here becomes the major one. But here is the minor arc. Okay. So if I want to find the length of the minor arc, you know the length of an arc is what? Theta on 360 times 2 pi r. Okay. So we have to know the angle at the center. Okay, the angle at the center. So we have to find the angle at the center, divide by 360, multiply by the circumference of the circle. So we have to look at the angle the minor arc subtends at the center. So what we can do, since this is a right angle triangle, then we can apply what? The SOHCAHTOA. If I'm finding this angle, then this side is what? If my angle is here, this side is the adjacent, and this side is the opposite. And then the side opposite the 90 degrees has always been the hypotenuse. Alright. So since the angle is here, then my opposite is here, then my adjacent, I can use the tan, I can even use cos, adjacent, hypotenuse, I can use sine, opposite, hypotenuse, and I'll get the same answer. So I'm going to find the angle. Since I'm looking for the length of the minor arc, then I'll use the angle to find. Okay. So we'll say that since I need the angle, let angle QOR be equal to what? Theta. Okay. So my angle QOR is theta. So if that is the case, then from the triangle, okay, from triangle OPR. So OPR is a right angle triangle. Okay, so I can say that, let me use tan, opposite on adjacent. Okay, opposite on adjacent, twice. So I can say that tan theta is equal to what? What is my opposite? The 12 centimeters. Okay, and then what is my adjacent? That is the OR. What is the OR? We have 5. That is the radius. Alright, so my theta is going to be tan inverse of 12 on 5. Tan inverse of 12 on 5. Then I can get my theta. So tan inverse 12 over 5. That will give us 67.38 degrees. Okay, 67.38 degrees. So I have my angle at 67.38 degrees. All right. Okay, so since now I have my angle here, angle at the center, then now I can calculate for what? The length of the minor arc QR. So therefore length of the minor arc QR, okay, we know is theta on 360 times 2 pi r. Okay. So what is my theta? 67.38 over 360 times 2 times the pi, which is what? 22 on 7 times the radius, which we had what 5. So I can now have my length of the minor arc as so theta on 360 times 2 pi r, where theta has been calculated as 67.38. That is the angle the minor arc subtend at the center over 360 times 2 pi r. So 67 on 38 divided by 360 times 2 times pi, 22 on 7, times our radius 5. And that will give us 5.8824 centimeters. So we're asked to correct to the what 2 decimal place, then that will be 5.88 centimeters to 2 decimal places. So this is the length of the minor arc, all right. So I think this is understood. And I saw one question where the question they have shaded this particular place here. Okay. And they were asked to find what? They were asked to find the perimeter of the shaded portion. Okay. So if it's the perimeter of the shaded portion comprised of the 8 centimeters, the Q8b, plus the 12 centimeters, plus the length of the arc here. So if it's perimeter of this shaded portion, then you add 8 plus 12 plus 5.8824. That is the length of the arc. Okay, so simple. And the question can even ask you to find the area of the shaded portion. So what is also the area of the shaded portion? That is the area of the triangle minus the area of the sector. Take note. This is a sector, you see. This is a sector. So area of the triangle. And then since this triangle here is 90 degrees, then we have our base and our height. Okay, so this is my base, this is my height. So half times, find the area of the triangle, half times 5 times 12, you get the area of the triangle. Then you subtract the area of a sector, because this is a sector. So here is a radius and here is a radius. So we find the sector, that is theta on 360 times pi r squared. Then you subtract the area of the sector, so that you get the area of the shaded portion. All right, so this is so simple. I know I'll see you again in my next lesson. Bye bye.